Actually, I actually asked the instructor about that, and I had to write it down, and I had to download for even Genie to work. Am I too loud or no?
No, you're
You're
fine.
fine.
Okay.
Let me find. See if I can find this video.
According to the I see some people are having some trouble with Java, so I'll just. I think I actually had the link. Let me get it out. Hang on.
This one I recorded from.
I'm just
the
gonna send the link to you real
office.
quick to make sure this is the right one. So I don't like send a virus site to everyone.
Oh yeah, that should have taken care of the path for you. Actually,
Yeah,
I'm surprised
I
that
think,
didn't.
Actually, that's what I used.
Here's the other way to do it.
Okay.
I'll link to this.
Oh, hey, I think I had this video last class.
Yeah, I uploaded this last year.
Yeah. I haven't looked at that to make sure I was doing the thing right, but yeah. I found a way around it, so yeah, I'm good.
For the lab, was the input text file supposed to have a new line character at the bottom?
Yeah, it doesn't matter one way or the other, or it shouldn't in terms of reading in ints.
Okay. And then was there anything special you wanted us to do with the file name, or will you just change it yourself?
So in terms of the name of the output file?
No, like the
class file?
The pathing to get the input file.
Oh, all that should be off of the same directory. So just use the file name.
Oh, okay.
So I'm going to have input.txt in the same directory as when I test these.
I have something related to the material of like last week. It's actually it really I'm just more curious. So when we're talking about like text files or bin files, usually it makes us either use scan or read and makes us know specific order how we want to find things. What if we didn't know the order of the things we want to find? How would we input it so we will read the whole file if we didn't know what was in it exactly?
Well, if you don't know what's in it, you don't know how to read it. Because a binary file is just binary. The only things that you will know about that file is there's going to be groups of 8 bits forming bytes. That's a given. But apart from that, if you don't know what the data is, reading it is dependent upon knowing what type of data it is. And I'm actually going to talk a little bit about this today.
Okay, I just want to like ask like something like dumb or something. I just
yes. So if you don't know what it is, you can't really read it in any meaningful way.
That's interesting.
Okay. And you can try to make educated guesses as to what type of data it is, but
is there like I know it sounds stupid or like some movie X type thing, but is there any way you can make like a program to maybe help you read it or like
I mean, it's all so all binary data files. There's some sort of logic or pattern to it. There's some sort of program that generated those files. And given different types of files have different rules, there are actually programs that can try to determine what type of file it is. If you are running any sort of Unix, for instance, we can figure out that a file's type by doing something like the files command or file command. So if I try file read points.class, That is a compiled Java class file. It even tells me the version. And it does this by looking for various patterns. If I try this for an executable, so I'm going to go to a different example here. So there's an executable, and if I try file add, it'll tell me that this is a 32-bit ELF, which is a Unix executable. So there are programs that will tell you this, but for things that we're creating, so let me look at this file here. It doesn't know what it is aside from its data. Now, what that data is depends on kind of how did we create it and how are we going to interpret it. So if you are writing data to a file, you need to know the order in which it was written in order to read it back in a meaningful way. We can take a look at the data in a file. Like if I do that, okay, this is telling me a little bit more. It's Java serialization data. So I know this thing contains probably Java objects. If I look at this in a hex editor, and a hex editor, like I mentioned before, it's just an application that allows me to look at binary data, 1 byte at a time. So let me open that. And again, we can see what that looks like, even though it might not make much sense to us. We can see, okay, well, point is there. So there's probably, if this is a Java object, we probably need a point class. But again, we need to know what was written there. Was there anything else written there? And in fact, there was, if we look back at that example. The first thing that was written to the file was an int, the number of points we're writing. The second thing that was written to the file was the point. So we have to know what's being written to the file in order to get that data back.
Okay, got it.
All right. To recap a few things, someone emailed me about one of the questions on the quiz, and I ended up curving the quiz by a couple of points
Thank
for
you.
a couple of reasons. One of the questions.
Oh, yeah, that I was about to ask. I ended up getting a 5 out of 5, even though I missed 2.
Yeah, so one of the questions was about file.
Well, you should
the
say
file class.
I forgot about it.
So the file class is used to create abstractions in our Java application for representing files and directories. It can be used for creating files. But what we're trying to do is we're trying to represent a file path in a meaningful way. And that path may or may not correspond to a file that already exists on the file system. So when we call the constructor, there is nothing created. you have to do a little bit more work to actually create the file if the file doesn't already exist. And that would involve either calling the create file method on the file object, which I don't think it's actually called create file, it's called something else, like create new file, or trying to write to that file. Either one of those will create a new file in the current working directory. Make sense?
Yeah.
Right. So the whole point of that was actually calling the constructor doesn't create a file. It creates a file object, which is an abstraction that represents a file path, which may or may not be a file.
Oh, that threw me for a loop. I was
That's what I was trying to get at, but I did not phrase the answer correctly, so that wasn't really a fair question. Most of y'all missed it, so I just, whatever.
Well, thank you very much. I appreciate it.
The important thing is to understand, though, what's going on when we create the file object, which in terms of the file system, nothing's going on.
Oh, were you talking about the question on the quiz?
Yes.
Okay, yeah, I was wondering that too.
Yeah. Does that make sense now?
Yeah, yeah.
All right, great. So I talked about object file IO. The two important takeaways from that. In order to serialize an object, that is, in order to create an object that we can write to a file or read from a file, it has to be an object that is an instance of a class that implements serializable. Everything inside that class, all the attributes, need to either be primitive or serializable or transient. If they're primitive, those attributes will just be written. If they're serializable, those object attributes will be written. If they're transient, that is telling the serializer, the stream, when we go to write an object or read an object, to ignore that one attribute. So that one attribute will be given whatever default value it would be given.
Professor Wyman.
Yeah?
I had a question about that because
Yeah.
whenever you did your example and you tried to print it or I think show it to the console, it was like null. So if you do something as transient, does it basically just like bunk that entire thing you're trying to use it for?
So if it's an object, it's going to be null.
Okay.
If it's a primitive, it's going to be whatever the default value is for that primitive. Which, if it's numeric 0, if it's a character 0, if it's Boolean, I believe false.
Okay.
What does it mean to be serializable? It means that objects of that class can be used by data input stream and data output stream. That's the short version. It means that the object can be serialized.
And you said something about like a
stream.
In order to utilize serializable, you said it has to implement it. Does that include with like text files in order to, will you not be able to use that then? Or
we're
are you
talking about writing and reading Java objects.
Java objects, okay.
Yes. Java objects, in order to be written to a file or read from a file, must be instances of a class that implements serializable.
And this is probably how like the beginning of a .exe file was created.
That's another story.
We are not talking about this.
Yeah. Yeah. So any sort of input and output stream. One of the reasons this was developed was, one of the reasons Java was developed was to utilize networks. It was developed primarily for the internet. Network support is built in. So if we wanted to send an object from one computer to another computer that is running the same application or similar applications that can utilize the same object files, we'd still have to serialize the object, and we'd still use an object input stream and an object output stream. The difference is that it wouldn't be wrapping a file input stream and file output stream. It would be using network components, which we didn't really go into with this. I'm not really going to go into in this class, but you can find examples of that. Other questions? These are great questions because these are okay. Starting from where?
Well, we're about to talk about exe files.
Okay. So no, that's something different. Not going to go into that here. That is a type of binary file, but that's not really serializable stuff.
Well, doesn't the exe implement this type of stuff a lot in order to be able to run the other files? Sorry, you don't have to answer if you want to.
An exe is an executable. It is generated by compiling something like C or C++, which generates executable files. This is not the same thing as serializing objects or writing object data to a file. In that sense.
Really quick, that private transient string color, you can't write or do anything with that because it's transient, I'm guessing, right?
Transient says ignore this attribute. Do not write this attribute to the file.
Okay, got it.
Or stream, not necessarily a file.
Why would you want that though? Like, could you give me an example of why that would be a significant thing?
One, we're talking about preserving data to files. There's some data that you probably wouldn't want to save to a file. It can serve space or because it doesn't make sense to save that data. Two, not every class is serializable. So if we have attributes that are object attributes that are instances of classes that are not serializable, we cannot write them to the file. If we try to, we'll get an error. So the only way we could write everything else that's in this object to that file, skipping over those things that aren't serializable, would be to make that attribute transient.
Got it.
All right. Other questions? Okay.
Wait, does bit checking happen while a file is being compiled to binary or while it is being read? Or how does that work?
What do you mean bit checking?
Like what happens, say you accidentally get a 1 where you're supposed to get a 0 in your binary file?
Depends on what the type of binary file is.
Okay.
So for the things that we're doing, depending on if we're writing an object to a file, where that 1 ends up being instead of a 0. We're not really talking about data validation. If we write something to a file and the bit gets flipped, something's wrong somewhere. And that could be device starts to fail. And that's never fun. If we're talking about an executable program where a bit gets flipped, well, if it's data or an instruction, if it's an instruction, that completely changes the meaning of the instruction. So our program's not going to do what it's supposed to do. At best case, it'll crash. Worst case, it'll do bad things. If it's data, same deal. Depending on what that data is, we could start to get garbled output. We could get all sorts of problems. But generally, that starts happening with hardware failure. And if hardware's failing, you got bigger problems.
Got it.
Yeah. Networking is a different story. Networking, you're going to want to have some sort of redundancy in sending and receiving data. And there's all sorts of utilities and wrappers for that sort of validation. But we're focusing on files here.
I have a quick question.
Yeah.
When it implements serializable, does that make this whole thing serializable or just parts of it? Because I kind of blanked out a bit.
Okay, so in this particular example, the object is serializable. However, that which is transient would not be serialized. It would be skipped over.
Okay. So anything that isn't transient will be skipped over. Is that right?
No, anything that
anything that isn't
is
serializable is skipped over.
Anything that is transient is skipped over.
Oh.
Everything
okay.
else must be either serializable or primitive.
Oh, I see. Okay, thank you for explaining that.
Those things that are serializable or primitive, those will be written to the file.
Anything that's transient will not be. Got it.
Correct.
Thank you.
So that's why in this example, wrote all these points to the file, set the color, and then when we went to read the file, trying to get the color, all of that was null because I set color to be transient.
All right, thank you very much.
All right. And again, all this is in chapter 17, so, and on the slides. All right. A couple more things I want to talk about with regards to file I/O. So what we've been doing so far with file I/O is whether it's text file or binary file, we've been working with streams. And streams are great, pretty easy to figure out how this works. You're just reading one value at a time. But they're also limited. They're limited in that we open the stream, we start at the front of the file, and we read. We read from the beginning to the end. Or we, and that's pretty much the only option we have, or we're writing from the beginning to the end. There's also ways to append to the end of a file. We'll talk about that at some point, but it's also in the text. But what if we wanted to be able to jump around in a file? That is, we wanted to be able to find specific locations in the file, read from them, or write to them. For instance, take this text editor. This is reading from the file 1 byte at a time. Each of these is 1 byte in the file. and I can jump around this. I could also use this to change values in this file, which, given that this is a binary file, a little bit dangerous to do, but I could do that.
But is it a good idea?
Is it a good idea? Well, it depends on what you're doing and if you know what you're doing. Let's take a look at what this file is. What's actually in this file. So I'm going to do read points. There's 2 points in this file. The values 1, 2, 3, and 4. Or 1, 2, and 3, 4, I should say. Those are doubles. I'm going to skip past some header stuff here. Try to find the int with the value 2. Now, how many bytes are used to represent an int in Java?
Is it a 4?
It's 4 bytes, or 32 bits. So since I wrote that number first, I can assume that this ACED00057704, that's header information. That's telling the system what type of file this is, most likely. Here I have 00000002. That's likely that int value, since 3 sets of 0 followed by 2. If I were to interpret those 4 bytes as an int, that would be the value 2. Let's change that to a 1. Save. This is pretty dangerous, but we're doing it anyway. Try to read from the file. It thinks there's only one object in there now, because it read that number and then used that number as the int. So, hey, we found a value and interpreted it. Make sense? And we changed the behavior of this. Now, if I change that value to 3, well, that's going to give me some problems. You can see, okay, it tried to read 2 values, and then it tried to read a 3rd value. And there's not a 3rd value to read. I hit the end of the file. Oops. Yeah, so there's an example of how a single bit can get you into trouble. It also kind of gives you a whole idea of how we can start to interpret this. So what comes after that 2? Well, something that says something about the class. And then we got the class name, P-O-I-N-T. And we've got more information. That probably says something about the class. Some of this is going to be numeric values, but it's going to be numeric values represented in double floating point precision. So interpreting that, not quite as straightforward. It's not like we can look for a 0, 1 to represent the base. We have to probably do a little bit more work. All right, so that's why it's important to know what we wrote to the file, what order we wrote to the file, because in order to read from the file, we have to undo all that. Make sense? Let's look at another file. So this is another binary file I created called numbers. Can I open it this way? Let's try it. Yep. So just wrote a whole bunch of numbers to this file as ints. And it's not that hard to figure out what's going on here if you just look at the values. So since it's just ints, nothing else, no objects here, nothing fancy, we can look, okay, 4 bytes, 00000000. That's 0. Next 4 bytes, 00000001. That's 1. 2, 3, 4, 5, and so on. So I just wrote the first numbers from 0 to 100. So you can see, I'm sorry, 0 to 99. So you can see there's 99. And if I interpret that number as a signed 32-bit, that's 99. But a lot of this has to do with knowing, again, what we wrote and where the positions are. Now I'm going to read from this file. I'm going to use a class that I haven't used yet in this class. What I'm going to use is something called random access file. So since I'm just reading, not writing, I can just use R. So the way this works is I'm not treating the file like a stream. Instead, what I'm treating the file like is kind of like an array or a list of values, bytes.
I like the way how the text editor has a line numbers on the side, and you consider each one of those to be a slot or a unit inside the cell of the array.
Yeah, yeah, that's a good analogy. But instead of say that, what we're doing here is I closed it. Each of these 4 bytes or 1 byte. So that's the first position, 1, 2, 3, 4, and keep going.
So whenever you turn it into a random access file, the file is treated as something completely different than what it used to be. Is that right?
It's not a stream, is my point.
Yes.
We're not necessarily starting at the beginning and going to the end.
Instead, you're just treating the file as if it's an extension of bytes in a way.
As if it's a collection of bytes.
Ah, I see.
So an array
like a
or a
pool
list.
something like that.
Yeah.
Data pool, database, something like that.
Yeah, so what we're doing is we have a length and we have a position. So I start at position 0, might as well start at the front of the file. I'm going to get the length of the file. I can just call the length method on that. And I'm going to move the cursor, or it's kind of like an iterator. I mean, it's exactly like an iterator. I'm going to move the cursor or the pointer to the start of the file. And then I can go through from beginning to end by changing this value and telling it to seek at that value. So the cursor is going to move every time I call raf.seek. Readint might also do it. Let me try that. Checking the values up here. Yeah, so reading an int or reading a long is going to move that position as well. But I still need to keep track of where I am in the file. So I don't actually need those seeks there. So starting at the beginning of the file, I'm going to print out the values as ints, which is what I wrote to the file. So that makes sense. You can see if I do that, what I'm going to do is I'm going to do, while I have not reached the end of the file, I'm going to print out the value that comes out of read int. So I'm reading the int value at that position. And then I'm going to, this is just to keep track of number of ints I've written to a line so that I don't, just to make the output nicer. Then I'm going to increment the position by 4. So this is just a counter to keep track of how many bytes have I read so far. Have I reached the end of the file? If I've reached the end of the file, that is number of bytes I've read is not less than length, then there's nothing more to read. I could also read this as longs, but that's going to be 8 bytes, and that's going to change the interpretation of those values. For example, so same sort of thing, but because it's 8 bytes, I'm going to be counting by 8 instead of by 4. But notice I didn't have to close the stream and reopen it. I was able to just jump around in the file. Like I was able to go right back to the beginning by telling it to seek at 0. So it's a lot like iterator, and we'll be talking about iterator some more when we talk about array list, which will probably be next week. So what's the output of this? Well, if we're treating it like ints, it's exactly what we expect. The value is 0 through 99. If we're treating it like longs, that's going to change the meaning drastically, because it's going to be taking 2 int values and reading them like a single long integer value. So
how would you be able to fix this problem? Like, would you have to rewrite it?
I mean, it's not a problem. It's just showing we have a binary file that we are reading in 2 different ways.
Okay.
The issue here, none of the contents of the file has changed. We're just interpreting that data in 2 different ways. I didn't write to the file at all in this program. Kind of just trying to drive the point home. You need to know what you wrote to the file, the order you wrote it in, and how many of what you wrote in order to make some sense of this. But you can jump at any position in a binary file, interpret any data as anything, and get something back. Now, if it's expecting a string or a character is a subset of binary values. So if it's expecting character and it doesn't get back a character, well, there might be some issue there. You might end up with something that can't be interpreted as a character or a string. And depending on what system you're using, what programming language you're using, that'll get you into trouble. So there's other examples of this. If I go to the slides here for chapter 17, You can see some examples of this. Let me jump to where it talks about random access file. You can see how to use this in object file IO, object streams, serializable, transient. So that talks about how those objects are treated when you try to serialize them. You can serialize arrays. Any array of object type serializable. So if all the elements in an array are serializable, then the array is serializable. So you can just write an array to the file. Random access files. So we've been treating read-only, write-only streams. This allows us to read-write, so not explicitly just read or just write. So I could use those sorts of examples to read from or write to the file. So you can use it to change values in the file as you're reading from the file. So just walking through this makes use of a file pointer. Random access file consists of a sequence of bytes. There's a special marker called a file pointer that is positioned at one of these bytes. Read or write operation takes place at the location of that file pointer. When it is open, the file pointer is set to the beginning of the file, which is 0. When you read or write, the file pointer moves forward to the next data. So if you read an int value using readInt, JVM reads 4 bytes, and the file pointer is now 4 bytes ahead of the previous location. So here we've got a file pointer. If we call readInt, it's going to move 4 bytes that way. Make sense? And if we called read long, it would move 8 bytes. Methods we have are the same as the methods available in data input stream and data output stream. So read and write primitives. We also have seek, which will throw an IO exception. Start from the beginning of the file stream to where the next read or write occurs. Get file pointer returns the current offset in bytes from the beginning of the file to where the next read or write occurs. So, strictly speaking, I could modify this even more. See if that is less than the length. And this would work pretty much the same way. So once get file pointer reaches the end of the file, those two things would be equal. Length, write char. Write char is going to write the char character as 2-byte Unicode with high byte written first. And then write chars writes the file, writes a sequence of characters. and you can open it for read and write or just read. And you can check the example that's here to see another example of working with a random access file. And I encourage you to look at that. I'll upload this example as well. But I think this is a better example, actually. So you can see here, read int. So reads the first number, seek. This line here is redundant because it's moving from the first number to the second number. It's already moved for us. Read int reads the second number. If we want the 10th number, seek 9 times 4, read that int. If we wanted to overwrite, say, the 11th number with a value, we could just do write int. And you could take a look at, like I said, play around with this, look at the different examples, look at the slides, see what you can do with this. We'll be doing more of this on Wednesday, and we'll talk a little bit more about text files and Unicode on Wednesday as well. A good exercise is taking a file and being able to determine if it's text or binary, and if it's text, what type of text file it is. So a thing we'll talk about is how different operating systems manage a certain aspect of text file representation. So there's not going to be a new lab this week. I looked at how people were doing in terms of the lab. So if you are still working on the current lab, I'll be available during lab hours. If you have any questions, please pop in. Otherwise, that I think is it for today. Are there any questions?
Nope.
Only question
Good.
I have is like one that's my Windows thing. So yeah.
Okay. Yeah, look at the video.